Hello, my name is Allison Harvey, and this video is going to be focusing on how to use the chain rule when solving derivatives, or when finding derivatives. So starting out with some theorem, the chain rule states that if we have function h of x equal to g of f of x, which is a composite function, then h prime of x is going to equal g prime of f of x times f prime of x. So a main thing that you really want to keep in mind whenever we're doing the chain rule is that the inside function in this case is f of x and the outside function is g of x. So another way to word this is that h prime of x equals determinant of the outside of original times determinant of the inside. Another way to put this, or also seen in our textbook and other platforms, is this notation. Don't want to screw up his name. Leibniz notation, dy over dx equals dy divided by du times du over dx. Do not cancel out these du's. This can also be seen in the form of the derivative of f evaluated at u equals f prime of u times u prime. So now that we kind of have all of that theorem in mind, let's look at some examples. So example 1 wants us to use the chain rule to find the derivative of 3 times x plus 1 squared. So what are we going to do? Step 1, we're going to find the derivative of the outside function. So let's identify what our outside function is. Our outside function is 3u squared. So we're going to take the derivative of our outside function. The derivative of our outside function is 6 to the 2 minus 1, which is just 1, and we're going to keep the argument the same. So it's 6 times x plus 1 times, our next step is to find the derivative of the inside function. So times the derivative of our inside argument, which is x plus 1. Moving on, so we get the statement that f prime of x equals 6 times x plus 1 times the derivative of x plus 1, which is just 1. So using the chain rule, the derivative of f of x equals 3x plus 1 squared is x plus 1, or 6x plus 1, excuse me. The derivative of f prime of x equals 6x plus 1. I'm sorry, that should actually be 6x plus 6. Let me fix that so that we know. This is actually 6x plus 6, my apologies, because we are supposed to distribute the 6 to both terms, not just one. Common mistake, make sure you don't do that. Next example, we have f of x equals 6 times 17x plus 5 to the 8th power. So remember, step 1 is to find the derivative of the outside function. Let's identify our outside function. So our outside function is 6u to the 8th. So we're going to keep our inside term the same. We're just going to find the derivative of our outside term, which is going to be 8 times 6, which is 48, to the 8 minus 1, which is 7. Just using the power rule here, which I stated over here. Remember, when finding derivatives, remember the power rule, which is that f of x equals x to the n. Therefore, f prime of x is going to equal n to the x, n times x to the power of n minus 1. So that's just the same idea that I'm using down here for these examples when I'm finding the derivatives. So again, we get the statement that the derivative of this outside term is 48 times 17x plus 15 to the 7th times, next step is to find the derivative of the inside terms, times the derivative of 17x plus 5. The derivative of 17x plus 5 is 17. So we're going to multiply this entire term together, and we get the statement that f prime of x equals 816 times 17x plus 5 to the 7th. Next, we're going to look at some trig examples, just because I think it's important to go over them. Sometimes we get confused and we think that just because it's trig, it's harder, but we're still going to use the same idea of outside function, inside function, keeping that inside function the same when we find the outside derivative, and then multiplying it by the derivative of the inside. So we have example, f of x equals sine times 5x. Sine is considered my outside function, and 5x is considered my inside term. So the derivative of sine of u is going to equal cosine u. Remember, we keep the inside term the same, so that's cosine 5x. Next step is to multiply it by the derivative of the inside term, which is 5x. So the derivative of 5x is 5. I'm going to multiply both of these terms together, so I get the derivative of sine 5x is 5 cosine 5x. Next example, is f of x equals tan squared x. Now on the surface, it looks like tan x could possibly be like my outside function, but do not be confused. We need to rewrite this. This is equal to tan x squared. Now it's very obvious what my inside and outside terms are. Tan x is my inside term, u squared is my outside term. So I'm going to find the derivative of the outside term first, which is 2u, keeping the inside term the same. It's 2 tan x times the derivative of the inside term, which is tan x. The derivative of tan x is secant squared x, so I'm going to multiply both of these terms together. 2 tan x times secant squared x gives me the statement that the derivative of tan squared x is 2 secant squared x tan x.